A nylon cube resting on a horizontal surface has a volume of 64 centimeters cubed. So immediately I think, okay, that's 4 centimeters for each side length. A force F is applied vertically downwards on the top face of the cube, so it compresses the height by X. So it's compressed a little bit. The graph shows a variation of F with X. What is the Young modulus of the nylon? So we have some options here about what it could be. Well, the formula for Young modulus, if we start with this, is the stress, defined as the force per unit area, over change in length over length. So X they've used here instead of delta L. We combine this, we get F over delta L times L over A. Well, we know L is 4, and we know A is 4 times 4 for that cross-section. So the L over A term will just give us a quarter. This is F over delta L times a quarter. And then F over delta L, if you notice, is just the gradient of this graph. So we need to try and think of a good value to use here in order to work out the gradient. So F over X or F over delta L. So zooming in, maybe it'd be a good idea to look at 1. So at 1, if we go up here, we get this value, which is how many squares along from 100. So these are divided into 10 squares, and then this is about 4 above, so that would be 120 newtons. So that means the gradient is 120 over 10 to the minus 6, which is just 120 times 10 to the 6. So if we pass over 2 zeros, we'd get 1.2 times 10 to the power of 8. So going back to our equation, we would have 1.2 10 to the power of 8 times a quarter. But if you notice, this is a quarter, which was 4 centimeters over 16 centimeters squared. So this is 1 over 4 centimeters. So we need to convert that 1 over centimeter term into a meter. So we need to multiply this by 100. Since 1 centimeter is 100th of a meter, so a 1 over centimeter, so using this unit would give us 0.01 meters to the minus 1, which is 100 per meter. Well, naturally, what you could have done is just converted the centimeters into meters from the get-go. So we could have had 0.04 meters over 0.04 squared. So we get 1 over 0.04, which is just 1 over 4 times 100. So putting this together, we get 100 over 4 is 25, then 25 times 1.2, so that's times 1 and a fifth, we would get 30 times 10 to the 8. Passing over that 10, we get 3 times 10 to the 9 newtons per meter squared, or Pascal, depending on what units the question would like to use. So the answer is F, 3 times 10 to the 9 Pascal.